Hello everyone, I'm Sian Proctor. I'm the Science Communication Education Outreach Officer on the Jody's Resolution Expedition 383, and I'm here with physical properties scientist Lester, and you know I don't know how to his last name. He's
problem.
You're German.
I'm German, yeah.
Yes, and say your last name one more time.
Lemke-Jenen.
Lemke-Jenen.
Yeah.
And Lester, why X-rays?
Okay, so actually this is a machine which we can use for various purposes. So we both use that for the same setup than you see on the other side here for whole round logging and tracking. However, relatively recently there was installed a different device, so X-raying cores, both either the whole round sensor logging or the half rounds. We use that to get a better idea about how the sedimentary facies inside the core really looks like. So how the different sedimentary deposits have been evolving, if there is a lot of bioturbation, so basically little critters going through the sediment and mangling everything through, which we would like to sample later, have disturbed the sediment, whether we see, for example, unconformities in the sediment, or whether it's a continuous sequence over time. And X-raying sediment half rounds is a very good measure to do this. It's a very good and fast way to get a good picture idea of what is going on.
Okay.
So this is the device which is basically clad in lead, of course, to protect us from the X-rays once this is on. At the moment this device is not running because we're just splitting the core, and it will soon go back onto these tracks. So you have basically a principal X-ray machine inside here, hidden between these beautiful cabinets. And what you do is you have the same setup in terms of the tracks than on this machine. So you have these long rails where we put on the half-split cores, and a pusher is then putting the sediment, and you can see the pusher core here inside this chamber, and then producing X-ray images of the core. And here's some of the examples of that. So basically what you can see from these images is how the actual sedimentary deposits are deposited over time. You can see that this is a fairly uniform sedimentation here, not much in terms of being disturbed. If you go to these sediments here, you can see here probably some worms, some animals going through that, living in the sediment at the time of deposition in the upper centimeters of the sediment, bioturbating the sediments, basically eating sediment and pooping it out at the end. And this is bringing, of course, a lot of disturbance in time series. Usually what we do to reconstruct climate is to go through these cores centimeter by centimeter, trying to reconstruct various parameters which give us indications about past sea surface temperatures or ocean ventilation. So if you have one of these worms going through the sediment and mixing all that up, that is of course a thing you would like to know in advance before you sample these cores. And this is giving us some of the information about that.
What is that?
So we do have some instances where we have deposited material which is causing these anomalies here. So in some cases these are just disturbances, images disturbances. In others these are ice rafted detritus materials. So basically grains or like large stones which are transported by sea ice or by icebergs into our depositional environment.
Oh, cool.
So that means that if you're looking at the X-rays, you can already start to count the larger, what we call drop stones, basically, stones or like small gravel or sand grains which were deposited not by dust or by rivers into our environment, but which came in by icebergs, and once the iceberg melts over the site where we drill, they will just raining down through the ocean column and give us an idea about either sea ice or iceberg dynamics, and that can be basically tracked then back to glacier history in the hinterland, for example, of Patagonia. So we're close to Chile in this case, so maybe that was glacial outwash. These are actual photographs for X-rays which come from the pelagic South Pacific. So this is probably ice transported material which came from Antarctica. This is the most farthest environment where we would probably get such a sedimentary environment, where we deposit still some gravel and drop stones from Antarctica.
Thank you. That was great. I'm going to cut us off here.